Hello everybody, this is Mr. Kessler here to teach you solving a system of linear equations by elimination. Once again, a system consists of two or more equations, and the solution to the system is the x and y value that will work in both equations. So to solve a system of equations by elimination, your first step is to eliminate either variable by creating a zero pair and then combining like terms. Second step, solve for the remaining variable. So in this first example, let's solve a system of equations by elimination. First step is to find a zero pair. So in this equation, we actually do have a zero pair, negative 3y and positive 3y. We're looking for a zero pair that we can combine with the same variable. So next step is to combine the two equations to eliminate one of the variables. Watch what happens. Combine like terms, 4x and 2x, like terms. Add them together, you get 6x. Negative 3y, positive 3, add them together, you get 0. Eliminate the y. And finally, negative 4 and positive 34, combine those together, you get positive 30, x equals 5. So we're suggesting that the x value in our solution to this system is 5. Let's find out what the y value is by substituting 5 in for x in one of the equations and solving for y. You're going to subtract 20 from both sides to get the y all by itself, negative 24. So y is equal to positive 8. So when x is 5, y is 8. That should work in both equations. Now let's test to make sure. We're going to use the other equation, the one we haven't used yet. So we're going to use this one. 2 times the x value plus 3 times the y value should equal 34. 10 plus 24 does equal 34. It checks. So now what I'd like you to do is I want you to try your hand at solving this system of equations using elimination. Pause the video. Pause it. I hope you paused it. Here is the solution. Notice there's a zero pair right here in the x values, 2x and negative 2x. So when we combine the two equations, always combine, you're adding them together. You get 5y equals 15, divide by 5, y equals 3. So if y is 3, let's find out what x needs to be. So in the middle here, you solve for x. Substituting 3 in for y. And then you work that out and you get x equals 0. To check it, we're going to use the other equation. We use this first equation right here. We use that first one, 2x plus 4y equals 12. To find out what x needs to be. So now we should check it with the other equation, and when you check it, it works. Finally, one more example. Oh, look at that, kid. If neither of the variables form a zero pair, you must multiply before. Okay, so sometimes in systems of equations, you're not going to have a zero pair staring you in the face. So here's the method to get it so that you do have a zero pair. Remember, I can do anything I want to an equation as long as I multiply both sides by that same thing, right? So I'll still have an equivalent equation. So in this case, negative 2x plus 3y, I don't have a zero pair in either of them. But I could multiply the first one by something. And then I could also multiply the second one by another value. If I multiply the first one, I'm going to suggest multiplying it by positive 2. And then I'm going to multiply the second equation by negative 3. I draw an arrow to show that now I'm going to write an equivalent equation right next to it. So every term in this first one gets multiplied by 2. Watch what happens. And then I'm going to multiply in the second one by negative 3. Every term. Now, do we have a zero pair? We sure do. The y's become a zero pair. So let's combine like terms. If x is 2, what is y? Let's take original equations, not the one that you created. Take the original equations and plug in 2 for x. Let's use the second equation. 5 times 2 plus 2y equals 12. 10 plus 2y equals 12. Subtract 10 from both sides. 2y equals 2, y equals 1. So our solution to this system is 2, 1. You can check that on your own time. Now go to find the 6.3 quick check. Solve or answer all the questions. You got to get a perfect score, so keep trying until you get a perfect score. 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 Bye, everybody.